May 15, 1963. The place, Launchpad 14, Cape Canaveral, Florida. The event, Project Mercury's final manned flight in Earth orbit, forerunner to Projects Gemini and Apollo in the nation's space program. Witnesses of the event, the people of the world, on the site in Florida, at television screens throughout North America and Europe, and at radios on other continents. High above Cape Canaveral, an aerial camera records the launch. The primary purposes of the fourth American manned orbital flight were to confirm how well man can function in space during a day and a half of weightlessness, and to test the efficiency of the human being as a primary component of a spaceflight system. The story then begins and ends with man. Man as a living, thinking element of the spaceflight system, and the man as an individual, the man who named his spacecraft Faith 7, for his faith and for his friends. The individual, Air Force Major and NASA astronaut Leroy Gordon Cooper, Jr. What events in his life led to his selection as the man who would take America's longest stride in space? He began flying at an early age. He soloed at 16. He became an Air Force lieutenant and jet pilot at 22. He also obtained an aeronautical engineering degree and qualified for the daring and methodical work of a test pilot. By the time he was selected as an astronaut, he was a trained, experienced test pilot of supersonic jets. But the demands of spaceflight were new, beyond anything previously demanded, even from a supersonic test engineer. New knowledge was essential, new academic training, from astronomy and celestial navigation to studies such as astrodynamics, spacecraft structures, bioastronautics. As an astronaut, Gordon Cooper entered another world of sensation, such as weightlessness, the absence of gravity, which can be simulated on Earth for only brief periods. He underwent hours of training on centrifuges, experiencing the forces of acceleration. He learned special breathing techniques to help him function under the crushing forces of liftoff and re-entry. He learned firsthand the sensations he would encounter in a tumbling spacecraft, and learned to control the craft's attitude in various dynamic conditions. Astronaut Cooper flew dozens of training missions on the ground in spaceflight simulators. He learned operational procedures and emergency techniques. He became as familiar with his Mercury spacecraft as with his own home. And if something went wrong with that spacecraft, he was trained to survive on the desert, in the open sea, wherever he might be forced to land in an emergency. By the morning of May 15, 1963, astronaut Gordon Cooper, engineer test pilot, was as ready to orbit the Earth as his own intelligence and the resources of science could make him. Ready as a man, a highly qualified person. But more than that was required. He must also be prepared as the component man, part of the control loop of a spaceflight system. Obtaining medical knowledge of man's mind and body in a period of sustained spaceflight was the most important goal of the mission. To take his temperature, a new oral thermometer was used. When not in use by the astronaut, it is stowed on the right earmuff of the helmet and serves to confirm suit outlet temperature. It consists of a thermistor embedded in a latex probe and has a range from 75 to 105 degrees Fahrenheit. Delicate sensors obtain heartbeat and respiration rates. They're placed on the torso and under each arm at the 6th rib level. An electrolyte material aids in conducting the electrical signals. This tiny microphone is worn by the astronaut for taking his blood pressure. It is positioned over the brachial artery on the upper left arm. To measure his blood pressure, the pilot presses a button on his instrument panel. A special cuff is inflated on his arm, much like those in everyday use in a doctor's office. The electrical outputs of the microphone and cuff pressure, like other bodily measurements, are fed into this single telemetry unit, are converted into electronic signals, and transmitted by radio to doctors on Earth. Repeated use of this exerciser during flight was also programmed to yield additional cardiovascular data on exertion while weightless. Relatively free movement of his hands and arms is possible for the astronaut during normal flight since his suit is not normally pressurized. The atmosphere within his cabin is maintained at a life-supporting pressure. In an emergency, however, should the cabin lose its pressurization, the suit would be automatically pressurized to protect the astronaut. A careful test of the suit is made just before flight to be sure there are no leaks. When Gordon Cooper left the astronaut preparation facility, Hangar S at Cape Canaveral, to board the transfer van that would take him to the gantry, he knew that his spacecraft had also been prepared for the mission with meticulous care. Faith 7 had been mated to its Atlas launch vehicle days before. Over 100 changes had been made from previous Mercury spacecraft, time-consuming changes in miles of wiring, in solenoids, valves, dials, and even in screws and bolts. The most important ones, such as removal of the periscope, were designed to reduce weight and increase space for storing greater quantities of consumables, oxygen, attitude control system fuel, food, and water. New instruments, such as cameras, antennas, and a metal sphere with flashing lights. In addition to medical studies, 12 special experiments were scheduled. The 95-foot space vehicle consists of the reliable 3-engine Atlas booster and sustainer, the spacecraft, and the escape tower. Mated together, these major components of Mercury Atlas 9 were a towering tribute to the energy and brains of the nationwide industrial team which created and united them. From almost every state in the Union, materials, designs, parts, components, and assemblies had come to this Florida beach, from the thousands of men and women working in the nation's effort to succeed in space. No one was more aware of the work of more than 50,000 people leading up to this moment than astronaut Cooper as he entered the spacecraft. He was fortified by the knowledge that thousands more would be standing by from Mercury Control Center to stations around the world. Emergency rescue forces were ready to come to his aid in the event of failure or catastrophe during liftoff. And other rescue crews were stationed at strategic points beneath his flight path in case of emergency landing before the completion of the programmed 22 orbits. The day before, the MA-9 flight had been postponed due to a radar problem at the Bermuda tracking station. The man, the space vehicle, and the support systems must check out 100% before liftoff. There's no margin for error when a man is launched into the void of space. On May 15, 1963, the countdown proceeded faultlessly.
Woomer, how do you read?
Green, reading loud and clear.
Roger. Canton, how do you read?
Status is green, clear with background noise.
Roger.
Around the world, all tracking stations were green for go.
This is Texas Capcom, read you loud and clear. All status is green.
Roger. Eglin, M&O, how do you read?
Evan, M&O, reading you loud and clear. All status is green.
Roger. Test 465 is at T-minus 24 minutes and counting.
MA-9, the vast and intricate edifice itself, responded perfectly to the careful scrutiny of men like those who had built it.
Stand by for status. Airman. Go. ECS. Go. Sequence. Go. Electrical. Go. ASCS. Go. RCS. Go. Com. Go. TM. Go. CO. Go. Flight. Go. Tony. I'm go. CO, I have your ready light. Roger. Airmed verify. Ready light. Airmed, booster interlock to go. Go.
Instrumentation, communications, the spacecraft's automatic stabilization and control system, ASCS, environmental control systems, all were go.
9, 8, 7, 6, 5, 4, 3, 2, 1.
Roger, have a lift off and the clock is operating.
That's your clock.
Sigma 7, base 7 on the way. Standing by to start the backup clock.
Roger. 3, 2, 1, mark.
Roger, and the backup clock is running.
Roger, you look good here, Gordon.
Roger, feels good, buddy.
Great sport.
30 seconds and fuel is go. Oxygen is go. Cabin pressure on the top peg altimeter is working.
Hey, Roger, you're looking beautiful.
What an afterburner.
That's the beauty of your clock doing thing.
As the spacecraft reached maximum dynamic pressure, all systems were go. As it rises, the vehicle is acquired and tracked by radar. Its automatic control is switched to the ground station. In the outer atmosphere, the vehicle is tilted toward the horizontal course. The escape tower remains in position to pull the spacecraft away from the launch vehicle in an emergency. At about 2 minutes 15 seconds of flight, BECO, or booster engine cutoff, will occur.
Sun is coming in the window now.
Roger, we're standing by for your BECO.
Roger.
Animation will show events beyond camera range.
Roger, BECO.
The sustainer engine drives Faith 7 toward orbital speed and altitude. When the spacecraft can escape with its own posigrade rockets, the tower is jettisoned.
And there goes the tower. And does she take off?
At 100 miles up and a speed of 17,544 miles per hour, SECO, sustainer engine cutoff, occurs as Faith 7 is inserted into orbit. 1 second later, it separates from the launch vehicle.
Step cap green, SECO, I'm on off stamp. Going fly by wire. Everything is green here.
Faith 7 was inserted into orbit exactly in the center of its programmed envelope. Using fly-by-wire control, astronaut Cooper then turned the spacecraft so that it traveled with the retro rockets and the heat shield facing forward. This way, the retro rockets could be fired to reduce speed and end orbital flight if necessary. The small jets of hydrogen peroxide, which change the spacecraft's attitude, have no major effect on the path or velocity of the orbital flight. At 14 minutes, 53 seconds, contact was made with the Canary Islands tracking station.
Phase 7, this is Canary Capcom.
Roger, Canary Capcom, Phase 7, reading you loud and clear. What temperatures would you like, over?
Capcom is the capsule communicator in contact with the spacecraft at each tracking station. In addition, 28 ships and 172 aircraft were stationed around the world in pre-selected recovery areas. Contingency forces were also ready in the event of emergency landing.
Phase 7, this is Zanzibar Capcom. How do you read? Roger, Zanzibar, reading you loud and clear. Phase 7 here.
An added advantage of having a man performing in the spaceflight environment was indicated by astronaut Cooper's ability to keep a detailed record of his flight on the onboard tape recorder. For example, approaching his first night.
First night side, and I have a bright blue band, a thick diffused band of blue color, a bright blue band. The sun spread out very widely. Is setting now. And there it goes.
Phase 7, Perth has their lights on tonight. You might look for them and see.
Roger, I have the lights of Perth in sight, loud and clear.
From the perigee or low point of 100 miles over Bermuda to the apogee or high point of 166 miles over Australia, the first orbit was nearly perfect. Capcom at Guaymas, Mexico, gave astronaut Cooper his go for 7 orbits.
Colonel, we're giving you a go for 7 orbits.
Roger. For 30, how many?
As many as you want.
Roger.
If all was well, in the 7th orbit, he would get a go for 17, then for the full 22. Meantime, he began the special experiments. The first was the use of this slow-scan television camera to relay pictures to the ground at the rate of 1 picture every 2 seconds. These pictures resulted from a transmission over Florida. 15 minutes before sunset on the 3rd orbit, Major Cooper prepared to eject this sphere or beacon for another experiment to find out how well man can see flashing lights in space to help with rendezvous and docking maneuvers in future space programs.
And I am on fly-by-wire. I've armed the squib. Pitching up very, very slowly. And we'll deploy the flashing light minus 20 degree point. Flashing light is deployed.
Once ejected, the beacon assumed its own orbit, which kept it at varying distances from the spacecraft. Major Cooper was unable to find it on the third orbit. However, on the next orbit, he saw the light clearly.
Quite bright, quite discernible. At the order of a second magnitude star now.
Beyond 10 or 12 miles, the flashing beacon became less discernible. In the fourth orbit also, the first of a series of tests were begun to measure radiation in space, where a belt of fission electrons trapped in the lower regions of the Earth's magnetic field would be penetrated by Faith 7 on orbits passing over eastern South America and the South Atlantic Ocean. Primarily, the measurements were made by two Geiger counters located on the retropack. One of the Geiger counters surveyed a hemisphere-shaped area unobstructed by the spacecraft and unaffected by radiation scattered by its structure. The other registered radiation directly in the path of travel. Trapped electrons spiraling along the Earth's magnetic flux lines were primarily the source of radiation. Several devices were provided to measure radiation piercing to the interior of the spacecraft. A pocket ion chamber, or dosimeter, a film patch attached to the hatch of the spacecraft, a photographic emulsion pack carried on the instrument panel, and 4 film patches worn beneath the astronaut's pressure suit, one in his helmet, the other 3 on his body. The packages contained 2 kinds of film, one sensitive to protons, one sensitive only to electrons. Both the nature and the amount of exterior and interior radiation at the Mercury orbit altitude were ascertained during the flight and found to be well below the level harmful to man. Astronaut Cooper was able to drink water successfully in his weightless condition, but he had some difficulty in transferring the water needed to make some of his packaged food edible. Experimental foods were freeze-dried and dehydrated so that adding water would restore their taste and consistency. Other foods were packaged in bite-sized bits. Small sandwiches, brownies, and other dessert-type foods were easily eaten. Other experiments were highly successful. For example, on the 6th orbit, astronaut Cooper clearly saw a 3 million candle power light shining up from Bomfontein, Africa. Such a light may be used to guide future moon explorers on their return to Earth. He carried out several experimental photographic assignments, such as taking pictures of the Earth's horizon or limb, which may also serve as a navigation fix in longer space flights. Another photographic research project involved use of a 35mm camera to shoot 2 dim light phenomena best observed beyond the Earth's atmosphere. One is called zodiacal light, believed to be a weak reflection of sunlight from free electrons and dust particles. The other dim light phenomenon he photographed was the Earth's night airglow layer, a weak 3-colored band of light around the Earth. Time exposures with a 35mm camera will yield data on the height and intensity of these layers and on solar energy conversion processed in the upper atmosphere. Infrared photography of the Earth on black and white film was also performed for the Weather Bureau to obtain data for the design of improved television cameras in future weather satellites. From time to time, the astronaut also shot color pictures of scenes selected at random. This picture was taken of the Atlas Mountains of Africa. This is a view of the Himalayas, the Philippine Islands. Major Cooper also proved that deep, normal sleep is possible in a weightless condition, beginning his rest period on the 9th orbit. With occasional interruptions for short reports onto his tape recorder, he slept well for several hours. In addition to the telemetered medical data, awake and asleep, on his heart rate, temperature, respiration, and blood pressure, his voice pitch was monitored to determine his psychological condition. The flight proceeded with textbook perfection. Even after the cabin cooling system was turned off and using only the suit cooling system, cabin temperature stabilized at 96 degrees and suit inlet temperature at 59 degrees Fahrenheit. Far less oxygen and attitude control system fuel were used than had been anticipated. During the 15th night, during his 22nd hour in space, astronaut Cooper recorded a personal prayer, portions of which follow.
I would like to take this time to say a little prayer for all the people. Thank you for the privilege of being able to be in this position, be up in this wondrous place, doing all these startling, wondrous things that you have created to be with all our families. Let them know that everything will be okay. We ask it in thy name. Amen.
The textbook flight continued. All systems go, all perfect. On his 16th orbit, astronaut Cooper sent greetings to the summit meeting of African statesmen.
Hello, Africa. This is astronaut Gordon Cooper speaking from Faith 7. I am right now over 100 miles above Africa, speaking to the Zanzibar station. Just a few minutes ago, I passed Addis Ababa. I want to wish success to your leaders there. Good luck to all of you in Africa.
All clear, all systems perfect. Orbits 15, 16, 17, 18. 18 times around the Earth. Orbit 19 began at the 20th minute of the 28th hour. Faith 7 and astronaut Cooper were out of voice contact from Bermuda around more than half the world to Hawaii.
Hawaii Capcom, Faith 7.
Go ahead, 7. This is Hawaii, regional.
Oh, Roger. I wonder if you'd relay to the Cape a little situation I had out and see what they think on it. While turning my warning lights off and back on to dim, my 05G telelight came on in my telelight panel.
The .05 gravity light normally comes on after retro rockets have been fired and the spacecraft has begun to fall toward the Earth. It indicates deceleration on encountering the atmosphere. But Faith 7 was maintaining its orbital path and velocity. Therefore, the question was whether the .05 gravity switch alone had been triggered by a short circuit, or whether the entire automatic control system had skipped the programmed retro rocket and re-entry phase. Astronaut Cooper's message was immediately relayed from Hawaii to Mercury Control Center. By the time he passed over Cape Canaveral, beginning his 20th orbit, NASA and contractor engineers had broken down complete schematic diagrams of the spacecraft and were ready to spell out certain tests for the astronaut to make to determine the seriousness of the unscheduled light. By testing the automatic stabilization and control system's ability to acquire attitudes, astronaut Cooper determined that his ASCS system was not operating. He performed more tests and exchanged information directly with tracking stations and by relay with Mercury Control at Cape Canaveral. A machine seldom makes a mistake, but a machine fails. A man must not fail. Between the man in the spacecraft and the men on the ground, it was determined that astronaut Cooper would have to fire his retro rockets and control re-entry by hand. His autopilot had failed. Without a man to bring the ship down safely, the spacecraft and the mission's most valuable data would have been lost. The task was difficult, but the man was trained. On his final orbit, astronaut Cooper completed final checklists for retrofire and re-entry, reported final data. Each error of 1 second in timing would cause a 5-mile error in landing point. Near midway, at the selected recovery area for the 22nd orbit, the carrier Kearsarge, smaller rescue ships and aircraft had been alerted and were ready for emergency procedures. A minute error in Faith 7's re-entry attitude could also result in a perilous under- or overshoot of the recovery area. At the 30th second of the 56th minute of the 33rd hour of flight, astronaut Cooper contacted John Glenn on the coastal Century, Quebec, near Japan.
I'm looking for lots of experience on this flight. You're going to get it.
10 seconds before the 34th hour of flight, to assist astronaut Cooper in the critical timing, John Glenn began the final countdown.
10, 9, 8, 7, 6, squib arm, 4, 3, 2, 1, fire. Roger, a green one here.
Roger, I think I got all three.
Roger, how's your attitude, old Gordo?
Well, pretty fair.
Good show, boys. Real fine. They look like they came off right on the money on time.
Roger, I think so.
Astronaut Cooper had fired the retro rockets on the second. He jettisoned his retro pack. As the tremendous speed of the spacecraft re-entering the atmosphere built up a temperature of 3,000 degrees Fahrenheit, the ionized air cut off radio contact for a short time. Now it was a matter of waiting, hoping for contact to be reestablished, hoping for accuracy, hoping the chutes would open and hold. Faith 7 was picked up by radar 184 miles out and falling fast. Shortly thereafter, the main parachute was sighted. And so it ended. 34 hours, 20 minutes, 31 seconds. The flight of a man in space 22 times around the Earth, 540,000 miles, farther than to the moon and back, ended within seconds of its programmed time and within 4.5 miles.